Okay, so this is Lesson 34 Sprint, Part 3. So here's where we are going to do some practicing with different numbers. All right, so our first one is 9/8, and we are saying that it is equal to having 1 whole plus something eighths. So in our head, we've got to think of, all right, well, if we have this 1 whole, what does that really look like? Well, we know that we have 9 of these eighth pieces, and we know it's a mixed number because this is an improper fraction. Our numerator is greater than our denominator, so we know that there's a whole in there. We could almost do a number bond on this and say 9/8, and we could do a number bond, and we could pull out a whole, which our whole would be 8/8. So that's kind of like our whole right there. And we could also say, all right, well, what's left over to bond with it? Well, we've got 8 here, and I know we need to have 9, so we have 1/8 left. So if you think of this one over here, we have our 1 whole, and we have 1/8 left over. So that's over here, we have our 1/8. So if I drew a picture of this, I would have 1 whole, which is technically broken into 8 pieces, but they're all there, so I don't really need to take the time to like break them all into 8 pieces. But this next one, I only need one more 8th piece because this already has 8 pieces there. That's my 8/8, and I need one more little 8th piece. So that's where I would have to break this into 8 pieces, and I would shade in one of those pieces there. So now that's making our number sentence correct because we have 1 whole plus one more eighth is 9/8. I could, in my head, break this into 8 little pieces. And then you can visualize, oh, there's 8, 9. 9/8 is the same as having 1 whole, or 1 whole that I pulled out, and 1/8. All right, now let's go to our next one, 13/8. So we're working in eighths again, but I can tell automatically right now that, hey, this 13/8 is an improper fraction. So I know there's going to be a whole number in there because it only takes 8 pieces to make a whole. So I'm going to have 1 whole for sure, and then how many little pieces are left over of that? So if I was to draw this, I would have my 1 whole, and it's all there, and I don't necessarily need to really break it up, but if I was breaking it up in my head, how many pieces would it have? It would have those 8 little pieces, and I'm thinking of that in my head as 8 pieces there. And then I've got to add something to it, another few fraction pieces, so that I have 13 there. So I'm going to have to make another one, and I'm going to have to cut this one up into 8 pieces and think, okay, if I already have 8 in that 1 whole here, how many more little 1/8 pieces do I need to have to complete it to make 13 of them? So I've got 8, 9, 10, 11, 12, 13. So I need 1, 2, 3, 4, 5 more of those little 8th pieces to make it complete to 13/8. Okay, now we're going to move to 6. So now we have 11/6, and you can tell already that this is an improper fraction. Our numerator is greater than our denominator. We know if we drew a number bond, we could pull out the number bond, 6, 6, we could pull out, right? And so let's draw our 1 whole. And in my head, I don't have to break it apart because I know how many pieces are there. So I'm going to break it apart in my head, and I'm going to give you little dots just so that you can tell what I'm thinking. And I'm breaking that into 6 pieces just to remember in my head, okay, this is 1 whole, but it really has 1/6 little pieces there, and all of them are there, so it's making a whole. So here we have our 1 whole, and I'm going to try to get 11. I know I only have 6 of those 1/6 pieces to make that whole, so how many more do I need to make that complete? Well, I'm going to have to draw another one, and I'm going to have to break it into 6 pieces. And so I'm thinking, all right, I already have 6. I need to get to 11. So I have 6 there for that 1 whole. 6, 7, 8, 9, 10, 11. So I need 1, 2, 3, 4, 5 more little 6th pieces. All right, so that makes it complete. We have our 1 whole plus 5 more 6 that add up to be 11. Now, don't be mistaken of looking at this and saying, oh, 1 plus 5 is 6. All I need is, that's what the answer is 6, because is that true? No, this 1 is actually representing these little 6 pieces that we've cut up, right, to make that whole number. 6, 6, 6 is that whole number. Okay, now we're going to look at 17, 6. Now this one is a little bit trickier because we not only have 1 whole, we actually have 2 holes in it, right? So I could make this into a number bond. I'm going to make a number bond out here on this one. I know I didn't do it on all of them, but I'm going to do it on this one just so that you can see where we're coming up with 2 holes. Now if I pull 6, 6 out of here, that is 1 hole, right? But I could pull another 6 pieces out of there, because what's 6 plus 6? That's actually 12, and we have more than 12. So 12, 13, 14, 15, 16, 17. We actually have 5 more pieces there that we could pull out. So as you can see in our number bond, we have 1 hole and another hole and then 5, 6. So that's where we're kind of coming up with this 2 over here, is that we have 2 holes. And what else does it take? So if I drew my picture, I'm getting them kind of smaller. They don't look the same size. Okay, so here's 2. There's my 2 holes. How many more pieces do I need to make 17? Well, I got to think in my head, how many pieces were in these holes? Well, that's where we think of, oh, if I was to make this into a fraction, my denominator is 6. So in my head, I could break these pieces into 6, and that's where I'm going to come up with how many pieces are there in those 2. Well, there's 6 here, and there's 6 here, so that's 12, and I need a few more to finish out to get to 17. I'm at 12 so far. Let me break this one up into 6 again. And, oops, sorry, getting a phone call. And I'm breaking this one up into 6 again. And so how many do I need? I have 12 here, 13, 14, 15, 16, 17. I need 5 more of those pieces. So I have 5, 6. So I could say it's 2 and 5, 6. All right, so on that last one, we had to think about, all right, how many is really in that 2? Well, because we're working in 6, we have 6 here in this hole and 6 in this hole, so that's 12. And then we count up to get to the 17. 12, 13, 14, 15, 16, 17. All right, so lots of renaming. We are just basically renaming fractions so that they are equal between whole numbers and fractions.